everyone. Welcome to another tutorial of Spring Boot series. My name is Jairaj and thanks for joining again. So till now in our journey we have seen many important topics and we have reached a point where we are able to understand why there are so many technologies and especially with Mongo. And there are dozens of ways to connect MongoDB with application and there are many ways to perform various operations on it, which is confusing, but at the ground level all technologies are trying to solve the same problem. So before starting out actual technical discussion, let me tell you a little bit what happened when Spring community decided to create this amazing Spring Data project. So in one day in early 2010, team from Spring and team from Neo4j Technologies were having session and they were trying to integrate Neo4j graph-based database with the Spring framework. But what is this Neo4j? So I'm going to create a tutorial series on Neo4j too, and I have already given little bit information on various NoSQL technologies in my previous tutorial, and I'll put link into the description for that. And but now just understand one thing, that NoSQL databases are the databases which don't work with the SQL. There are few categories in this NoSQL database, such as a document-based database. Our MongoDB is a document-based example. Then we have Redis server, which is key value pair database. Then we have Neo4j, which is graph-based database, and we have Cassandra, which is column-based, column-oriented database. So these all databases have their own strong working area, and based on our use case and our requirement, we need to choose one. So when Spring team and Neo4j team were discussing various approaches for integrating these two technologies, that was the foundation of Spring Data. And at that time, Spring already had amazing support for traditional SQL technologies. So if you think about what kind of support we need if we want to develop a framework, especially database related, then we need to cover few areas such as connection. So connection between database and application, we have our framework should have to support a connection properly. Then we need to have resource management. So getting connection and releasing after use is a resource intensive process. So framework need a support for connection pooling and management of those resources. Then we need translation of exceptions. So every database related technology such as Hibernate, iBetis and Toppling and etc. So under exceptions, we call it native exceptions because those exceptions are native to that external system. So Spring doesn't know that exception, right? So we need to convert exceptions coming from Hibernate or Toppling or iBetis. We need to convert those exceptions into Spring related exceptions because Spring doesn't understand those exceptions, right? So we need to handle them or need to convert into Spring related exceptions so we can handle them later. And Spring have built-in support for that. So if you guys remember at the time of discussing JPA repositories, we have discussed that if you annotate Spring repository with @repository annotation, Spring will convert native exceptions into data access exceptions automatically. So no need to write extra code, and which is very convenient. And another support we need is mapping support. So we have to have something that can map our database object into our domain objects. And here domain objects are Java objects. So in JPA we have entity classes that we can use with some annotation for this mapping purpose. So in short, JPA supports all of this. So using JPA as a abstraction for NoSQL was the good idea in that discussion. But if you go with JPA at high level abstractions, then what about data specific features of NoSQL? So for example, graph based database should be used for storing highly interconnected data, which is data that you can represent in the graph form. Document based database should be used for tree and aggregated like data structures. And the key value pair database should be used for cache like functionality and access patterns. And additionally, what about all the other features that NoSQL database provides, such as geospatial functionality, map reduce operations, graph traversals, and much more? So we're not going to use it with JPA because for JPA those concept doesn't matter, right? So we have to implement those concepts into our old ways. And what about JPA based annotations? So such as in JPA we have annotations like @table and @column. But this annotation doesn't make any sense for NoSQL database because we don't have anything like table or column in NoSQL, right? So idea of using JPA as abstraction needed to drop because of these problems, and it needed to go with a new approach. But keeping consistency between JPA and this new approach was necessary because of the developer community to make everything smooth and less confusing, so we can use it with the other ecosystem of the Spring. And that's how Spring Data team came up with this new programming model that can be consistent for NoSQL and SQL, and it can also retain database specific features and capabilities. And the programming model was, instead of using single abstraction such as JPA, they used different modules for different database but with same pattern, such as template design pattern, and abstraction such as tables for SQL, documents for Mongo, and graph and relationship for Neo4. And that's why in Spring Data we have JDBC template, JMS template, Redis template, Mongo template, and Neo4j template, and much more. And this all have the same support for connection, resource management, exception handling, and mapping. So that's why Spring Data is very important in changing the course of database operations. It is easy to understand, easy to remember, and easy to use with significantly less amount of code, less amount of boilerplate code. And that's why I am a big fan of Spring Data team. So today in this tutorial, we will look into MongoRepository, which is one more layer on top of Mongo template. So if you open MongoRepository, you can see that it is extending two things. It is extending paging and sorting repository, and second one it is extending is query by example executor. And this paging and sorting repository extends CRUD repository internally. So that means we will have all the methods related with CRUD repository and all the methods related with paging and sorting. And let's go to Eclipse and create a CRUD operation to understand how we can use this Mongo repository. And for that we need one project. Let me go to my browser and start.spring.io, and here I need one project. So in group ID I am giving name Mongo, and in artifact I am giving test. And we're gonna need three different dependencies, which is Spring Web and embedded Mongo, and then we need Spring Data and generate. And let me go to my Eclipse and open it with Eclipse. So in Eclipse I need to go to file, open project from file system, then directory, and then download, and we have this test, open, finish. So here we need to go to pom.xml, and first thing we need to remove is that test scope from for embedded Mongo, because embedded databases are for testing purpose. So we need to remove this so we can use it for our regular purpose. So I'm closing this pom, and now we are ready to move forward. So for that we need couple of things. We need a controller, we need service, and we need a repository, and we need a model. So let me just quickly go ahead and create those things, and I'll come back. And we need one employee model class, and for that I'm going to create a separate package for that. So I'm going into class, and then here employee, and this employee will be stored in the model package, and I'm doing finish. And here I need to we need to write few fields. So what I'm going to do is I need to write string ID. So this ID we are taking as a primary key, so we need to annotate with ID. So what we are doing here is we are telling Mongo repository to consider this field as primary key or ID. And the second we need is first name, which is also string. Then we need private string last name, and we need private address. So I am taking address as an object, not a single string or something. And then we need salary, which is a float. Okay, and moving ahead, this address doesn't exist, so we need to go to create class, and here we need to create address, and inside address we will have few fields such as private string line 1, then we have private string line 2, then we have private string city private string state, then we have private string private integer and zip code, and we need few constructors and getters and setters. So let me create those. For that we need to go to source, constructor using fields, select all, generate. Same way I need to create a constructor without fields. So for that, constructor from superclass, generate, and here we need source, generate getters and setters, select all and generate. So that's how we can create this class. This is ready, so I'm closing it, and then in our employee class also we need the same thing. So in our employee class we need a source, then constructor from superclass, generate, source, constructor using fields. Here we don't need id, so because at the time of generating the employee we don't need id, so let me remove that and then generate. And then we need getters and setters. So source, generate getters and setters, and then select all and generate. Control Shift F to rearrange the code, and this class is ready, so I am closing it. So we have couple of annotation in our Spring Data. So something called @document you can use to make this employee class as a document entity, and here we have couple of things if you want to use. So if you do control space, you can see here we have this value. So this value you can put, let's say I want to store this employee in some collection name ABC, then I need to write value equal to ABC here, something like this. But if you don't provide anything, then it will take a class name as a default collection name. So in our case it will take employee, but with a smaller e. So now we have controller and service, but we don't have repository. So why I didn't create is because till now we used to create it as a class, but in this case we need to create it as a interface. And here let me give name as employee repository, and we need to extend a few things. So in extension I need to write Mongo repository. If I do this here, I can see here it is asking for two things. So these two things is, first one is employee because this is employee repository, and second one is ID. So if you remember, we use a string as a ID. So here we need to pass a string. So I am doing finish, and this class here we need to import this. So control space and then hit enter. So this repository is ready. So in controller we're gonna need few things. So first thing is our stereotype annotation. So here we need REST controllers, and then we need mapping, request mapping, and here we need to give the path. So I'm gonna give employee. Okay, same thing in service, we need a stereotype annotation which is @service, and in repository also we need @repository. Okay, and in controller we need to auto wire this. We need to auto wire service, so I'm doing employee service. Same thing, we need to auto wire repository in our service class. So add auto wire employee, control space, and repository. Okay, and we in this tutorial we're gonna need some more data. So what I'm gonna do is I'm gonna initialize our database with 10 or 15 dummy records. So for that I need to use command line runner. So if you don't know how to use a command line runner, and you don't know what is command line runner, then I have already created one detailed video on this. I'll put a link into the description. Please watch that to understand, and it is very useful sometimes. So just keep in mind one thing, that to use command line runner we need to go to our main class, and here we need to implement command line runner. So if you do command and then control space, you can see we have this command line runner, and now here we need to override the method from that command line runner. And if you go here in source, then override, you can see it will override this run method, and then okay. So inside this function we need to add some data into our database, and for that I need to auto wire employee repository, and then inside this I already have something written here. So what I'm gonna do is, let me go ahead and copy that. Okay, so here what I did is I created one list of employees, and I created some few 12 objects manually, and then I put everything into this list, and then I need to call employee repository, then insert, and I need to pass this list of employees. Okay, so now we are ready to move ahead, and we can create our API. So let me close this, and first API we need to create is our get API. So for that I need to do @get mapping, and here I need to pass some path. So I'm going to pass this only slash and then public and then list, which will be the list of employee get all, and here I need to call employee service dot get all. So this employee I need to import, and this get all function doesn't exist, so I need to create. So this same way this get all function also will call employee repository dot, and you can see here we have long list of all the functions, and in our case we need to do find all. So we will see all of these soon, but for now we need to use this find all and then save. So if I go to run, and then if I run this as a Spring Boot application, I can see we don't have any errors. Then let me go to Postman, and then here if I do get employee, and if I hit send, I can see I have all the data here. So we have 12 employees with different data in it, which we already initialize. Okay, so moving ahead, if you see here, we didn't write any code in our employee repository. We don't have anything here, right? Then from where this find all function is coming? So this find all function is coming from this Mongo repository. But if you see here, this Mongo repository is also an interface, right? So we need to have some implementation or some function definition, right? So this all function implemented in simple Mongo repository class, and it is coming from there. So this all function is already there. If you want to see how many function is there, you just go here and do dot, and you can see we have long list of different functions which is already made, already defined and implemented. You don't need to create anything. So that's how we can create CRUD operations with minimum code. If you see here, we didn't write anything. We didn't write any database specific code. So this is the power of Mongo repository. Okay, so moving ahead, we need to write one post API which will create if we want to add any employees. So I'm doing post mapping, and same way I'm not gonna put anything in this path, and this here let me do add employee, and this will return employee object. So whatever we are storing, it will return, but at the time of returning it will have ID, and it will take employee object in request body. So here I need to do request body and then employee, and I'm giving name emp. Let me give this emp into this add function, and I need to pass this here. So control save for that, and this function doesn't exist, so we need to create one. And the same way this function will call employee repository dot insert, and I need to do emp. So this insert function will return employee object that we are storing. So let me go ahead and test this function. So stop this application and restart this. So no errors. Let me go to Postman, and in post, in body, let me write something random. Okay, so let's say we have one man named ABC man, and then he is living in cave, and his salary is 8,000. So if I do send, you can see here I am getting everything back, but we have one additional field which is ID. So this ID is generating at the Mongo side. That means this is successfully stored. So you can create your custom response based on this returning object. Okay, so if you do get, and you can see here at very last we will have this ABC man as our employee. Okay, So next one we need to do put API. So let me go ahead in employee controller, and here I need to do put. So let me just copy this put mapping, which I need to import, and then so we are basically updating the employee object which is already there. So let me give name update here, and then this update we are passing this employee in this update function, and this update function doesn't exist, so let me create one. So let me copy this because its syntax is same, and here instead of insert we need to use save. So the difference between insert and save is insert will insert a new object all the time, and save function will look for that ID. If it found the ID, then it will update that existing object. If it doesn't found, then it will create a new object. So for that we need to do save and then stop the server, restart it, and if I go in my Postman, and then we have this Batman. So let's say I want to update this Batman salary. So Batman have 5,000 right now, and if I go into put in my body, let me paste this, and instead of 5,000, if I put 15,000, if I do send, I can see it has salary 15,000 and it is returning the same object which we stored. So if I do get again, you can see here the salary is updated. Moving ahead, let's create our delete API. And for that, let me just copy and paste, and here we need to do delete mapping instead of put mapping. We need to import this, and here we need to take ID. So the thing is, at the time of deletion we need something uniqueness. So you can fire a query, you can write a query, or you can pass directly ID or something like that. So let's say you want to delete all the employee who have first name John, right? Then you can write a query. If you want to delete a particular employee, then you can pass ID, because and this ID is a unique ID, so it will delete only one. So let me create this delete, and then instead of this request body we are using request parameter, and this is the name is ID, and then we have string. So we are taking this ID as a string and then passing this ID here, and then this update function need to replace with delete. So this delete doesn't exist, so let me go ahead and create one. So create method, and then here we need to call this repository. So we have, if you do delete, you can see here we have four options. So if we have something called delete by ID, and here we need to pass ID. So let me delete this extra thing. If I do save, I'm getting error. So this error is because this delete function is a void. It won't return anything, but it will generate an exception if something goes wrong. So you can use that exception and return something, some string value or some response based on that exception. Okay, so let me do void. We're not gonna return anything, so void control S. Then same thing here, we're not gonna return anything, so void. Okay, control shift F. Then here we have some error, remove this delete, control shift F and save. Stop the server, restart the server. If I do get, I have this employee, and if I want to delete this, I need to go here and then need to pass this as a ID. Okay, and if I do hit send, I get nothing here, right? So if I go in get, and if I do send, I won't see Batman anymore because we delete that Batman, right? So that's how we can create CRUD operations using our Mongo repository. And we don't need to write any implementation code in repository, no need to write any code for object mapping, no need to write any code for exception handling or conversion. So if you see here in our Eclipse, we didn't write anything. We didn't write a single line of code in our repository, right? No database related functions or anything. So all the functions we used here is already defined and implemented, and you can use this for our various purpose. But let's say we have a huge database with couple of thousands of employee record, and we have UI something like this, where we have search functionality, pagination, and total number of count, and number of pages and records should be sorted with the employee IDs by default, and then you can put other functionality in it. So in this case, if you go in our repository, so in repository, if you do dot, then you can see here all the list of functions, but we have nothing here in this list of functions that can help us to achieve this goal, right? So in that case, how we can achieve this? So we need to tell Mongo to give us data in page of chunks basically. So if you remember, I told that Mongo repository extends two things. If you open this Mongo repository, it is extending two things. So one of them is this paging and sorting repository, right? And here if I do dot, then we have this find all function with pageable, and it can take pageable or short. If you want to do short, then you can use this with short, and if you want pageable, then you can do with pageable, right? So let me go ahead and create one function that can fulfill our requirement. So requirement is we don't need all the data together. We need few employees, first few employees sorted by ID by default, and if you want to change, instead of ID, if I want first name, I should be able to do that, right? And we need to have page numbers, we need to have page size, and we need to have total number of employee. Okay, so for that, let me go to our controller, and here let me write that API. So first let me just copy this get API and put it here, and instead of get mapping, let me put here page, because we need to make it a little bit different than usual. And instead of list, we need to return map this time, and which will have string and object. Okay, instead of get all, we need to write something called get all employees in page. Okay, and here we need to write some condition that we can use. So first thing is we need to do this request parameter, and we need to take page number. So if I do here name, and we have this page number we can put, and this is not a required field. So if I pass something, then it will take that value. If I don't pass anything, then it will take it should take default value. So I can say something like default value equal to 0, because page number usually start with 0. So it by default it will show you first page. Okay, let me import this map first, and then here I need to give name, which is a string. I need to give a variable name with a type which is string, and then I need to take page number. Control save, and this should be string. Okay, the second thing that we need to take is, let me just copy this same thing, and the second element that we need to take here is the page size. So I can do page size instead of page number, and if I don't pass anything, then it will take page size of 2 by default. Okay, and same thing here, string and then page size. And similarly we need to pass something for sorting, right? I said by default it will take ID. Okay, and then if I pass something, then it will take that value. So for that I need to pass first name, last name, or something like that with some field name. So this is our function, and we need to pass all these three value to our employee. So let me just copy this function name, paste it, and here I need to pass this page number, page size, then we have sort by. Okay, this function doesn't exist, so let me go ahead and create one, and here we need to write everything. So first thing, we as I mentioned, that we need to generate a map which will be our response, which is string and object map. Okay, and this map will be our response. So let me create that response equals new hash map. Okay, and need to return this here, and in between these two we need to write that. So our this response should have all the employee details with data field. So what I'm going to do is I'm going to do here data, and I need to pass that employee list here. But first we need to call it, right? So we have this employee repository dot find all, and here we have this pageable. We need to pass this as a pageable. For that we need to create object of pageable. So first let me go ahead and create a pageable, which is pageable equal to this spring data domain, right? Then page equal to page request dot, I can pass here off. So this is the first is the page number, then we have page size, and then we have sort. Okay, so let me use this one. I need to pass page number, so we have this page number which should be as a string. So I can take this one as a integer and string, and here I need to change as integer, and the sort by will be the field, so we don't need to change that. And here we have this page number which will go here, then we have page size which will go here, but we don't have this sort. So let me create this sort object and give name sort equals sort, which has data domain dot and then by. So we need to do sort by, right? So this sort by, and we need to pass the name of the field. So here we have the sort by field like this, and pass this sort here and colon, and this pass this page here. Okay, but if you see here, this find all will return object. It won't return in the list of the employee, it will return the page of the employee. So we need to store that into page of the employee. So employee page, because so the reason why it is not returning the list is because in page we will have some more information. It will have all the other information related to that page. So first thing is we need to pass this all the data into this page dot. If I do get, we have content. So if you see here, all the content is in the form of list of employees. So I need to pass this, and now we need the total number of pages. So let me do something like total number of pages, and if I do employee page and if I do get, then we have this number of element, get pageable, total elements, and total pages. So this will return me the total number of pages. Then we have total number of current, total number of elements. So how many elements are there in total? So I can go here and do get number of elements. Okay, then we have this number. So this will return number of current slice. Then we have number of elements. We have get total elements. This function will return total number of elements we have. Then we need to pass current page number, right? So current page number, and here we have number which return the current slice. So slice is a page basically. If I do control save, and then if I restart this, and I need to call this as a page. So in here, if I do page, if I do send, I can see here we have total number of 6 page. Currently we are in 0th number page, and we have total number of element 12. So here if I do page size equal to, let's say, 5, and if I hit send, then we will get 5 elements total, but we will have total number of page 3. So why this is 3 is because it will start with 0, then 1 and 2. Okay, so we have total 3 pages where 5 and 2 elements will be there. So that's how we can use this pageable and sorting together, and we can create dynamic APIs. So moving ahead, we need search functionality, and we need function that can search by first name, suppose. So if you see, we don't have anything here. So if you go to our service, and let's say here, if you do employee repository, and if you do dot, you have all the list of functions. But here we don't have anything that can give us something like find by first name or something like that. Okay, so basically we need a custom method that can fire our query on the Mongo. So we need to create a query, and that function should fire our query. But if you go in this employee repository, this one is the interface, so you cannot write a function here. Okay, so that is the problem here. So there are a couple of ways to create methods that can fire our custom query, and we have 3 different ways, which are query by example executor, query by method names, and query based on JSON. So let's start with the first one, query by example executor. And so as we discussed previously, that MongoRepository extends 2 things. If you go here in MongoRepository, it extends 2 things, paging and sorting, that we already discussed. But the second one is a query by example executor. So what is this? So this is the interface that allow query execution by the example. So if you open our repository and see, we have find all. If you go here in our service and if you do employee repository, and so if you do find all, we have couple of option here that is taking example as an argument. So this example is an object that will help us to create a query based on this. So Mongo repository have an executor extended, and that executor will create query based on this example object. So what is this example? So example needs prob to get created, and this prob means the instance of domain class. So in our case, it is employee. We need to use employee object, which is our entity class, to create this example object. And query by example is a concept or approach where we create query based on example given. And it was originally created for SQL, but now we can use for NoSQL too. So internally, query by example executor will take an example object and it will generate query based on that. So for example, let's say we have a list of all the employees, right? And we want all the employees whose first name is John, suppose. So we need to create an example which will need entity class. In our case, it will look something like this, where first name will be John, but rest of the field don't matter. So we need to put it as null. So what example executor will do is example executor will will see this object, and based on whatever value we put it there, and based on whatever matcher we use for that, it will create a query on that. So for example, let's go ahead and create one API that can use this example executor. So for that, let me go to my controller. Let me just go here and first copy this get mapping, and here let me pass example here and change get all by example, and here we're gonna pass our employee object. Okay, so let's say in our case it will be something like request body employee. So let me just copy here and paste it, and same way copy this, paste here, and emp. Let me pass emp here, control shift F and save. But this function doesn't exist, so let me go ahead and create one. So now here we need to create our example object first. So for that, if you do example and control space, you can see we have this data domain example, and here we need to do employee because it will be using employee as entity class. And here let me give e equal to example, and where example will be example then dot, which is off. Now here I need to pass prob. So this prob is an object of our employee. So if you remember, we already take this from response. So what I'm going to do is here, let me use prob and emp here. And another thing that we can do here is we can create our custom matcher, but if you don't want to create one, then it will take a default matcher. Okay. So let me just do as it is for now, and then later we will see for example matcher thing. So employee repository, and if I do dot, I can say find all, where I can pass this example and I pass this e. Okay, control shift F to rearrange the code. Let me stop this and start. Okay, and let me go to Postman, and then here I need to do example, and in body I need to pass something like this. So just let me copy this, paste it here, and text JSON beautify, and we don't need this all other fields, we just need first name. So what I'm going to do is I'm going to remove all the other fields, and I'll do something like this. Okay, and let me beautify again. If I do send, I can see here I have one answer where first name is Aqua. Okay, so if I do this last name also, or let's say salary, if I do salary something like this, and instead of 10,000 if I pass 5,000, so it will, I won't get anything because it is taking AND operator. First name is Aqua and salary is 5,000. That's how it is taking, because we define matcher as a default. So let's say if we want to change this matcher, then what we can do here is we can create our custom matcher something like example matcher, then give names matcher equal to again example matcher dot, and here we need to do matching. So let's say if I do matching any, okay, by default matching any predicate derived from this example, and here I can do something like with ignore case, right, where we don't need to worry about case, and then we need to do with matcher, okay, and then here we need to pass that field name. So first thing is we are taking first name, and we are comparing first name as exact by default. So let's say if you want to do start with, then we can do generic property matcher and dot off, where we need to define what we want to do. So in our case it is a string matcher, and inside this matcher we have a couple of options. So if we want to do exact match, we can do exact match. If you want to do starting with or ending with, then you can go with this ending or starting object, okay, and this way we can define our custom matcher, and we need to pass this matcher with this employee at the time of creation of example, and it will compare based on that matcher. So this is our first method, and with this method we can create very complex queries, because if you see here we have so many other options too. You can do match all, then we have this null handler, string matcher, transformer, and so many other options, and using this all the options we can create complex queries with it. So let me just delete this, because we're gonna move forward. We don't need this matcher, so it won't give us error. Okay, so this was our first approach, and so second approach we have is a query by method name. So this approach we have already seen at the time of discussing JPA repository. It works same, where we need to define a function in interface, no need to write any code in it, but our function name should be proper with proper keywords. So for example, let's say we have all the employees whose first name is John, and in that case we are searching by first name, right? So our first name will be something like a find by first name. So let me go ahead and create one API for that. So let me just copy this get API, and here let me do post, and then here first name, and in get all let me rename this with get all by first name, and here we're gonna use this request parameter. So let me just copy that, paste it here, and instead of page number we're gonna do first name, and delete this, and we're gonna store this value in string, then first name, and pass this first name to this function. So this function doesn't exist, so we need to create this function. So create method, and here we need to delete this first, and then we need to call this employee. So our function name will be something like find by first name, and then first name, right? I'm going to pass this, and in employee repository I already wrote this function. So in employee repository, if you see, I wrote find by first name, and here I am not writing any code. I just provide proper function, proper method name. Okay, so let me just save this, stop this server, and restart this application. So if I go my Postman, and if I do first name, and where first name equal to bat, if I do send, then I can see I have one record. But if I do something like BAT, then I don't get anything. So this is case sensitive search. This is one of a limitation of this approach, because we don't have proper keywords. So what is this keyword? So in previous tutorial we already discussed, but let me tell you again about this. So here method name is a combination of three different things, which is prefix, property expression, and keyword. So in our case, if you see here, we have this find by first name. So find by is a prefix, and we can use read by or get by also instead of find by, and property expression is our first name. So with the first name, we are MongoRepository is basically recognizing the property. And the third thing is the keywords. So you can use and, or, less than, or starting with, something like that. So let me go to browser and show you something. If I go to browser, and if I do Mongo repository, query by method name, then we will get this link. I'll put this link into the description, and we have all the possible combination of function that we can create. So we can create greater than, less than, between, is null, like, regex, near, within, stuff like that. Okay, and this how we can create. So let's say if we want to do start with, then we can use something like this. So the starting with is gonna be our keywords, and let me refine this in our employee repository also. And here if I go ahead and let me delete this, we don't need that, and stop this server. And if I restart this, and if I go in browser, and if I do B, I can see all the people whose first name is starting with B. But if I do BA, then all the people is starting with A, stuff like that. So we can use these keywords to create a combination, different combinations. But let's say we need to find employees by zip code. Okay, so if you see here in our employee, we have address, and inside address we have zip code, which is integer. So it is it is inside the sub object, right? So in that case, how we can write this function name? So let me quickly create same API, but with a zip code. So let me do this here. Instead of first name, let me go at zip code, and we are taking this zip code, and instead of string we are taking as integer and zip code. Okay, and here let me give name find by zip code. Copy this, paste it here, then zip code, and instead of first name we have zip code. So this function doesn't exist. Let me go ahead and create this method, and here just copy this and paste it here. So this function not gonna work, right? So because this function is for finding with first name, but how we can write function name in this case? So what is happening internally is there is one algorithm, something called a property resolution algorithm, and that algorithm will scan this method name, and it is retrieving all the property names. And how this algorithm works is it will internally will split this entire method name with camel case from right to left. So in our case, it will split here with starting with and then first name, right? And that's how it is getting. So let's say if we want to take everything by zip code, then we need to do find by, because it is a prefix. Then we need to do address because it is inside the address, and then we need to do zip code. So what it will do is it will scan this property name, then start splitting it from left to right. So first it will get code and then address zip. So it will go into our entity class and try to look for address zip. It is if it finds, then go inside again. If it won't find, then it will split again, and it will move the splitting point one step ahead. So second splitting point here is this address and zip code. Okay, so it will go to our entity class and look for address, and then inside address it will look for zip code, and that's how it is creating this query. So if I do this, this function doesn't exist, so let me just go ahead and create one. So if I do create, then here, so if you see here, we are not writing any code again. So let me just stop this, restart, and in Postman, instead of first name, let's say if I do zip code, then here again zip code, which will be something like 3 and 4. So if I do 3, I don't have anything, but let's say if I do 7, I have one guy with zip code 7777. Okay, so that's how we can use this query by method name. You can create really very basic queries. You cannot create like very complex query, but it can save you a lot of time. So what you can do here is you can use this method in the combination of other approaches, and you can achieve your requirement quickly with this approach. So all the basic queries you can go ahead and quickly create like this and move ahead. So our third and final approach is query based on JSON. So what is that? So in this approach, we need to use annotation, something called @query annotation. So let's say we need to find a list of all the employees by salary greater than. So let's say we have some salary, something called $1,000, and we need all the employees whose salary is more than $1,000. So in that case, if we go with our JSON based query approach, And how we can create is, just let me copy this quickly, and then instead of zip code, let me do salary, then integer and salary. So we took this salary as a float, so let me take it as a float here, and then pass this salary to the here and get all by salary greater than. Okay, this function doesn't exist in the service, so let me just move ahead and create one. So here we need to do employee repository, and we have function name something called ABC. So here function name doesn't matter. Okay, we need to write query here. So let's just create this function first, and here on top of this function name I need to use query annotation. So if I do query and control space, I can see we have this MongoDB repository query annotation, and inside this, if I do control space, you can see here I can do searches here. So here you can do something like value equals, and here inside this I need to write a JSON query, and you can practice this query in our Mongo Compass client, or online also there are a couple of client is there, you can practice the query, but this is very simple. You can write a salary, and then we have this function called $, then GTE, which is for greater than or equal to, and then we have this question mark, means this field is dynamic and I'm writing 0. So what is this 0 is? So it will take the argument of this function as an array. So first argument here, in our case it is a salary, so we are writing 0, but let's say we want first name, last name, and stuff like that, then you can write query here, and then you can do question mark 0, question mark 1, stuff like that. So but for now this is more than enough, so let me go ahead and save this, and if I do stop this server, restart again, Postman, if I do salary, and instead of zip code, if I do salary, let me do 1000, if I hit OK, then all the people who have salary more than 1000 I can see. Okay, but let's say I do 5000, then I can see fewer records. I have all the people whose salary is more than 5000. If I do 10,000, then more than 10,000 only. So that's how you can use this query. But there is one more feature here. So let's say if you see here in Postman, we are getting all these fields, right? So basically we are ticking everything all the time. But let's say we want only first name. We don't need last name, address, and stuff like that. So you can go to your query, and here if you do control space, you can see something called fields. So inside these fields, you can write whatever fields you need. So let's say you want first name, so first name, and this should be in like a single quote. Then I need to do 1. So 1 is for true and 0 is for false. So I want first name, so that's why it's true. If I don't want ID, I can do something like ID colon 0. And if I do save, stop the server, restart the server, and if I go in my browser and if I do send, I can see all other fields are null. Okay, but still we are getting here. So what you can do here is, we have something called JSON built in Spring. So just go to your property file, and here if you do spring dot JSON, then you can see we have something called property default property inclusion. Here you can do like control and space, and you have all the options that you can put it here. So let's say I want non-null, means all the non-null properties I want to see, all the null property will be ignored automatically. Okay, so if I do stop this, restart this server, and in Postman, if I do send, I can see only first name. So if I do, instead of 10,000, if I do 5,000, I can see all the people whose salary is more than 5,000, but only first name. So that's how you can reduce down the amount of data that you're going to download at the time of firing this API, and you can request only those information that you need. So let's say we have one table in our UI, and over there you are just listing all the first name and last name of the employees and employee IDs. You don't need address, or you don't need any other information, right? In that case, you can use this functionality and create those APIs. So that's all for now in this tutorial, and in this tutorial we have seen many important topics, and I suggest you guys to go and practice on this topic. And in upcoming tutorial we're gonna discuss actual Mongo. So till now we were using embedded Mongo, but in upcoming tutorial we're gonna use external Mongo, and we will perform same thing. We will use MongoClient, we will do Mongo template, and then we will see Mongo repository. So that's all for now in this tutorial, and if you have any questions, put it into the comment box, and don't forget to like and subscribe. Thank you very much.